Hi, everyone. I'm so excited to be speaking at the ScyllaDB Summit today. And here we are today going to talk about CI/CD for data, meaning how can you test your pipelines the right way by building development and test data environments with lakeFS. And I am V now, the developer advocate at lakeFS. As you can see here, I started off as a software engineer and then on to data and ML engineering. And currently, I work as a developer advocate for lakeFS. lakeFS is an open source data versioning engine that can offer Git like interfaces for your data lake. And let's jump right in. Now, as data engineers, this is exactly how our life looks like, right? You expect our pipelines to run in a predictable way, the way we programmed, but that Spark job is not going to run exactly the way you coded. And this is what we end up with. One small schema change, there goes your on call weekend trying to fix something in production that is on fire, right? What can go wrong with our data pipelines on a day to day basis? As a data engineer, I've been guilty of doing some of these things. I'm sure you have few of them, all of them, or even more than what is in this list. Spark or EMR upgrades, of course, any infrastructure upgrade that involves our data pipelines are bound to go wrong. And remember the tiny schema change that the business wanted you to update or the upstream forgot to mention because there was no data contract in place, and also the KPI definition that got updated by the business. And now you have to rerun or backfill all the data thanks to running the pipelines all over again. Troubleshooting the failed Spark jobs and non-idempotent pipelines so you can just rerun them anytime you hit failure in your Airflow DAGs. And now the most absolute favorite of all is the legacy DAGs that nobody in your team wanted to touch. But now you need to make a minor upgrade to some logic in the DAG, and you never know what goes haywire in which part of the DAG, with hundreds and hundreds of tasks and whatnot. There are like literally like the list goes on and of what are the things that can go wrong with our data pipelines, right? But why is it so complicated? Why are dealing with data pipelines that hard? It is because the data lifecycle is a bit different from the software application development lifecycle, right? When you look at the data lifecycle, you have multiple data sources that are writing to the central repository that is data lake house, whatever it may be, depending on your environment today. Now, all these ETL pipelines, multi-step complex ETL pipelines that are running on this raw data to make them into a more, consumable format, curated, ready for consumption by the downstream. Now, on the downstream, we have multiple consumers, sometimes even concurrently trying to read the data of your data lake. And not only that, right? For a typical software development lifecycle, start with the data sources and consumption, it is done. But with data lifecycle, thanks to the privacy regulations and whatnot, now we also need to take care of all the way till the data deletion takes place, right? So monitor and debug and all the way to data deletion is this complex data lifecycle. Because of this is why we hit a lot of these challenges in working with the data pipelines on a daily basis. Now, because of all these changes, we need to come up with an effective testing strategy to test our data pipelines. But then, though, do all of us test our data pipelines? Not so much. So, here you can see the poll that I posted on Reddit Data Engineering from actual data engineers working in different companies. And it is fairly understandable because as data engineers, we are running against hard deadlines, and some of that means we need to deliver the data or we need to serve the data by the end of the week rather than focusing so much on building best practices to ensure the data quality or building effective testing strategy for our data pipelines. So we need to do the unit testing, integration tests, and end-to-end tests and whatnot. End-to-end tests because the data pipelines are not isolated. They are connected to multiple data sources and multiple data consumers on both ends. So end-to-end testing is absolutely needed to ensure the data reliability and quality. Now, all right, you agree that we need to do the E2E test. Now what? How are you going to test that? Some of us, copy production data outside of the production environment into a test environment. Some of us try to create mock data because it's easy to kind of create a template schema and then go around creating some data to kind of test your pipeline before you deploy it in production. And some of us try to sample the production data, trying to optimize for variety, volume, and velocity, and replicate the production data into a test environment. But then none of these strategies are effective because in mock data, it will not represent the real life production data to test your pipelines. But when you copy the production data outside, you are going to run into data privacy violations thanks to HIPAA, CCPA, GDPR, and whatnot, right? So now, how exactly are we going to deal with building an effective testing strategy? For that is exactly why we need CI CD for data, meaning we will apply the engineering best practices to data engineering and build CI CD for data product instead of a software product. And let's go ahead and see how we can exactly implement this for your data lake, right? What would be the CI/CD best practices? In the application development world, there are three different phases, right? Build, test, and deploy. So let's take these phases and see how data best practices or CI/CD for data best practices can be in each of these steps. In the build phase, of course, we would place all the data assets under version control. Instead of source code version control, we have data version control here. And in the test phase, of course, we want continuous integration tests to be run automatically before promoting the product to the next stage. And to run these continuous integration tests, we also need isolated environments, the data environments to be spin up in an automated fashion. In the software world, we would be spinning up a Docker container or a temporary sandbox environment to run our tests. How are we going to do that in the data world? We will see that later in the presentation. And in the deployed phase too, we want to run a suite of tests, and only if those tests are successful, we want to go ahead and deploy the product, be it software or the data product, right? And then even after deployment, even after all these checks and tests that you might run, you would still end up with some data errors in production because the data is constantly changing at the pace that you could not test them in. Now, for such scenarios, you also need to have automatic rollbacks in place, just like a git revert, if I can say so. Now, how are we going to implement these best practices in these three different phases of deployment into the data world, right? Let's take the first one. Version control your data in the build phase. This is exactly where the lakeFS comes in, right? What lakeFS offers is a Git-like interfacing capabilities for your data lake, and it offers version control. As you can see here, what I have in my data lake is a delta table, which has a delta log and a couple of Parquet files partitioned with date. Now, we do have table level abstractions thanks to databases. So we have two tables, table 1 and table 2, and we have our data lake here. Now, what lakeFS can do here is it can offer branch level abstractions on top of the tables, meaning just like in Git, you can create data branches, say main, v1, v2, and whatnot. And the data in all of these branches are isolated from each other, and it can give you those Git-like interfaces like branch, commit, and whatnot to work with this data. And for example, right here you can see that this particular delta table is sitting on top of any of these data repos. It could be S3, Azure Blob, or GCS, right? And let's kind of deep dive in and understand. Suppose if you have your data lake today on an S3, how can lakeFS work with it? Yeah, lakeFS here, as you can see, sits on top of these object stores. Again, it could be S3, Azure Blob, or even like MinIO on-prem object store, for example. lakeFS sits on top of these object stores and offers Git-like interface. It could be the lakectl command line utility or the lakeFS UI or several language API clients. Do you work with Python? Do you work with Java, Spark? lakeFS has gotten API clients for all these languages, so you can easily work with lakeFS. And suppose currently your data consumers or the data applications like Kafka, Spark, Airflow, Athena, Hadoop, Trino, and whatnot, the existing host of applications that you have today can either access the object store directly or can access them through lakeFS with data versioning enabled. And with lakeFS, the data versioning is not limited to just table level. It can be enabled at the repository level, meaning an entire S3 bucket can be versioned and kept track of. And now, as a data engineer, you also want to make sure that the introduction of a new tool or a software does not intervene so much, or it does not disrupt your existing code base, right? If you look at the right side here, just by installing and having lakeFS as part of your storage layer, all you need to do is just simply add the name of the branch. Here, the name of the branch is main. So just add the main branch to the S3 prefix and you're good to go. With minimum level of intervention into your existing code base, you will be able to achieve data versioning on your data lake with the help of lakeFS. But then, how does lakeFS work? Is it going to create a copy of the data every time I'm going to create a new branch? Not at all. What lakeFS does is it does zero copy cloning, meaning it only copies pointers that are pointing to the objects underneath. And as you can see here, we have two different commits that point to the same pointers, meaning they share the objects that are underneath. And anytime a new object is created, it is going to do copy on write, meaning it will write the new data and then create pointers for that new data and add it to that commit. Just by doing this, creating a branch is a few millisecond operation. Imagine you have your production data that has, I don't know, like a few terabytes or even a few petabytes or hundreds of petabytes of data. And you can create a new data environment to run your tests. So copy all of the hundreds of petabytes of data into a new test environment. It is going to take a lot of time, and also storage is not free. Just by using lakeFS, you can do that in a few milliseconds, and you're not utilizing your storage costs at all. You're not increasing your storage costs at all. Zero copy cloning of your existing production data into a test environment. So you have all the data that is in your production for testing your data pipelines. This is interesting, right? Now, for the next phase, we only talked about how do we enable versioning for your data lake. The next is though is about how do we run integration tests on an automated, on-demand test data environment. Now, lakeFS also offers this feature called lakeFS hooks, and using that, you can have the CI tests run. And as you can see here, the hooks can be used in several different ways. One way is that on the ingestion side of things, before you ingest any data into production, you always want to run a suite of tests, and only if those tests are successful, you want to ingest the newly arriving data into production. You can leverage lakeFS hook for this. And now on the experimentation side, let's say there is an error in your production and you want to troubleshoot what is going wrong. Instead of directly working with production, you could simply create a branch out of production and then look at what's going on. And suppose if you have a hot fix that you want to test on production, you can do that as well. And if the fix is verified and approved, then in the end, you can merge it back to production, overwriting whatever was in the production, meaning overwriting the error with the hot fix that you have tested in your test branch. So there are several different ways in which you can leverage lakeFS hooks to implement the CI part of the pipeline for your data lake. Now, once we have all these tests run, right? Suppose despite running all these tests and checks and the quality validations, what happens if there is an error in production? The first thing that you want to do is you want to be able to revert to a previous state that was consistent, that was error free. Because at any point in time, your consumers are still consuming data from your production. So the first thing you want to do is revert to a consistent state of data that is available for your consumers. You can do that as well with lakeFS revert. Now, let's go over a quick demo of how you can use lakeFS and build a development or test environment, run data exploration and data cleaning in the test environment. And once the data cleaning is done, how to write the clean data back to the main or back to the production branch. I have my lakeFS running locally on my Docker container, as you can see here. I have lakeFS on the port 8000, and I also have Minayo locally running at 9001 and the Jupyter notebook at 8888. And this is a sample Jupyter notebook that the lakeFS team has put together for you to explore and play around with the creation of development or test data environments with lakeFS. Now, first things first, let's go over and explore the lakeFS UI. You see an example repository here. It's just like a Git repository. We have a lakeFS data repository. And once you go in there, you see there is no data currently, and it has only one branch, which is main. No uncommitted changes. The only commit was that the repo was created, as we saw the main branch, no tags, nothing to compare, and so on. Now, let's go to the repository and let's go ahead and create a new repository and add new data and see what it looks like. And I'm going to be doing that from my Jupyter notebook, the API, using the Python lakeFS API. And let's go ahead and install these first. All right. This is just the installation and the configuration step just to connect lakeFS to the Jupyter notebook so we can run everything programmatically. And what I'm going to do here is I'm going to create a new repository called Netflix movie data, right? Before that, I also need a storage layer to sit underneath. So I am going to create a new Minayo bucket, and I'm going to call this Netflix movie repo bucket. Awesome. So we have this bucket, and now let's take this bucket and let us create a new lakeFS repository on top of that. Go create a repository, blank repository, and let us call it Netflix movie repo. And the S3 bucket, the Minayo bucket that I'm going to use here is Netflix movie repo, which we just created. I'm using Minayo here and I'm using S3 as the prefix in here because Minayo supports S3 like API and lakeFS can work with any object store that supports a S3 like API to work with. So let's just keep the default branch as main and let's create a repository. So we have the Netflix movie repo. So let's go ahead and create these branches as well. And I'm creating two branches here. One is the ingress landing area branch, which will contain the data that is coming in from our data sources. And the second is the staging area branch where, we will be doing all the pre-processing, cleaning, and, of the data before actually pushing it into production, right? So currently, let us try to list the branches, and it should only have the main branch because we only had main branch here as well. We didn't create any new branches. Now let's go ahead and create the new branch, which is the ingest branch. And I also created the staging branch. And once I have both the branches created, let's see. Awesome. So I have ingest landing area, main, and staging branches here for me. Let's go ahead and check that in the UI. And if I go to branches, see, I have three branches. And one interesting thing that I want you to notice here is that branches have the same commit hash. Because I created these two branches from main, and since all of them have the same data underneath, since we've not changed anything yet so far, they all have the same pointers to point to. Meaning they don't copy the data, they just reference the same objects underneath in the object store. Now I have my movies.csv locally, and I'm going to upload that to my ingest or ingress landing area branch. And let's do that and see what changes have happened here. We just added a new file, which is movies.csv under this path, right? So let's go here in the ingress landing area. Awesome. So we have that data that has landed. Now, the next step is let's commit this data in the ingress. And once you commit, you can see here who is the committer, the creation date, and all the commit metadata that goes in. And just like the git commit message, you can also add any commit message. And you also have an option to add the metadata as well. So do you have the specific diagram that has committed this data? You have that option to add the diagram here as well. Or any other metadata that you want to add it to each commit, you will be able to do, which will help you with tracking the data very easily. And let's go ahead and see the commit again. Awesome. So we created this repository and then we put the Netflix data into the landing area. And what next is let us copy this data from our ingest area and to the cleaning or the staging area. And we'll just do a simple pre-processing, see what the data looks like, a bit of data exploration, and so on. So we have copied the data to staging area. And if we go to staging, we should be able to see our data in a bit. So this commit is okay. So reading the data file with Spark is taking a bit of time. Awesome. So this commit is successful and we should be able to see this here now. Okay, so we have the data now in the staging area for us. All good. Now let's go ahead and do some exploration and see what the data looks like, right? And it's just the movies data and it is going to have a few columns, like just 8,000 records for us. And you also get a glimpse of what the data looks like and so on here. Looks good, it's fine. Let's go ahead and see if it has any null values or anything that we need to clean up, right? And let's go ahead directly to the null checks. What is going on? Yeah, so it does have a couple of null values in some of these columns. So let's just simply drop these. You might have a different, way or a strategy to deal with these null values at work, but here for the sake of the demo, I'm just going to drop them all. And now the data looks clean, no null values, everything sorted. And what I'm going to do here is take that data, partition it by a different column, by a country column here, and I'm going to save them as Parquet files in my staging environment. So let's go ahead and do that. What I'm doing here is when I go to the staging area, you see the raw data which we copied. And again, in the staging area, we also have analytics. We are saving the data in the Parquet format by a different partition as well. And it's the Spark job's running. It's taking a while. We don't have success here yet. So there are different countries. We're partitioning them by just, it's going to run for a second. Is it done? Okay, so this is successful. We have that as well. And we have also we need to commit this as well, right? Because anytime you do these changes and go here and see, you should be able to see the uncommitted changes just like in Git. So the uncommitted changes are the analytics files, movies, by different partition. And you can also have a look at the change log of each of these files. That should let you see what the changes are before you actually commit them. Now let's go ahead and commit these as well. Awesome. So this commit is successful. And when you go here and see the commits, we had copied the data and now we have loaded the partitioned files in the Parquet format to the staging area. All good. I think I wanted my files in the Parquet format. I wanted my files to be partitioned by country. Also, no null values, all clean data. Now I want to push this data into my production, right? All I'm doing is merging my staging branch into the production branch. So the source would be the staging branch, destination is my prod branch. Currently, I want to show you before we merge what is in my prod. The prod is essentially the main branch. Currently, we have nothing because we kept it clean. We only wanted the cleaned, rightly partitioned Parquet files in main. So let's go ahead and merge this and see what happens. Awesome. So no conflicts. Everything is good. Let's go and see what happens. Awesome. So we do have the files here from the staging area. And if you go to the commits, you should be able to see all the commit history, the changes that happened or the data lineage of the repository being created, copying the data from ingest to the staging area, doing all the changes, and then eventually deploying them in production, right? And there it goes. So at the end of it, testing was like the staging branch was just a temporary sandbox environment we spun up for testing our changes locally or cleaning up the data locally. So the end of it, it's up to you. You can either go and delete a specific branch because you think you're done with the sandbox environment and you don't need it anymore, or you can go ahead and keep it for running on other tests as such with the data. But here I would like to delete it and just move forward, and that is it. So we're done with the demo. Now that you know you can create these development or test data environments with lakeFS to test your pipelines and to clean up your data, let's go back to our presentation and see what else can lakeFS do for you. All right. So now we're done with the demo and we saw how you can use lakeFS to build your development or test data environments. Now, off to the next phase, which is the deploy phase, right? It is fair that for the build phase, you use lakeFS for building data version control. And in the continuous integration test phase, you use lakeFS to run a suite of tests before deploying your data into production. And in the deploy phase, though, we want to highlight how lakeFS can help you achieve the data quality checks and also do automatic rollbacks of production issues or production errors. Now, like I said, lakeFS has this feature called lakeFS hooks, which are conceptually very similar to Git hooks, meaning you can have these hooks enabled on a specific, I would say, action, Git action. For example, if you're creating a Git branch or committing it or merging it, or for any of these actions, you can have a lakeFS hook. Say a pre-commit hook. So anytime before you commit it, it is going to check or run a list of checks, which you can configure. And only if those set of checks are successful, will lakeFS let you do the commit. For example, in our case, right, when we merged our data into production, we can have a set of suits run for us. Or you could even have a great expectations or Soda.io run a suite of tests. And only if those tests are successful, we would want to deploy our data into production. And now, once you have that, like I said, there may be instances, despite all of these best practices in place, you will still end up in production errors where lakeFS offers the revert option as well. So, in one command, you will be able to revert from your error state of production to a very consistent, the right state of production data so your consumers can consume the data while you're troubleshooting what went wrong in production. And you can also have like a post merge event or a post commit event configured for lakeFS hook to do this programmatically as well, right? And so today, when you have lakeFS in your data lake, what can you do with each of these phases is, first of all, in the build phase, you will be able to build the data lakes with different versions enabled for you, meaning you can time travel between different versions of your entire data lake, not just at the table level, not just at the object level, but at the entire repository level. You can do time travel. And when it comes to testing, you can test a pipeline on an isolated testing branch without risking your production data at all. And in the deploy phase, you can revert back from potential production errors, again in just one line command by using lakeFS. And here we have a bunch of companies who are using lakeFS and who are contributors to lakeFS and who are lakeFS champions as well. And if you are, like I said, lakeFS is an open source project that gives you data versioning capabilities. So if you want to try out a POC or just think about how lakeFS can help your data team with different use cases, feel free to reach out to us at lakeFS.io for the documentation or for any specific questions regarding use cases and whatnot. And we also have a thriving and active community of Slack users, lakeFS users on Slack who discuss the best, data architecture and the best practices in data engineering and whatnot. So feel free to join us if you have any questions as well. Thank you so much. And that's all I have for today.